start, first thing we need to remember is what is absolute value? I think most of us can probably notice the symbols, right? What do the symbols look like for absolute value? Yeah, it's just the vertical bars, right? And so we'll have these vertical bars like this. And we know those symbols mean absolute value. And we would read that in the equation as the absolute value of whatever. So if I take the absolute value of 4, what do I get? You get 4. Okay. If I take the absolute value of -4, what do I get? I also get 4, okay? Now the question is, why is that? Why is both +4 and -4 4? So the question is, what is the definition, or what does absolute value mean?
Is it the distance to 0?
This distance from 0. Yep. Good. Okay, so when I read this, when I say the absolute value of 4, the question you can really ask yourself is, how far is 4 away from 0? Well, it's 4 units away. If I do the second one, if I said, what's the absolute value of -4, the way I would really read it is, how far is -4 from 0? It's also 4 units. And the reason they're both positive here is because we're talking about distance, right? When we talk about distance, we don't ever use a negative number. I'm not going to go drive somewhere and say, oh, I drove -30 miles to get from here to here, depending on what direction I went. If I go north, south, east, or west, I would say I went 30 miles to get to the next town, or whatever, okay? We never use negative values for distance. And so whenever we get an answer here, our answer will be positive. The only way you would get a negative answer is if we have a negative on the outside of the absolute value. And then it would kind of be like an absolute value type question where I take the absolute value of 8 and then put a negative on my answer. And that would become -8. Okay. So that's just kind of a quick basic intro and kind of remembering what absolute value is. When we look at the equations today, it's not going to necessarily be solving them because we've already seen absolute value show up. Like going back to chapter 1, when we did order of operations, we had absolute value in some of those things, and we had to evaluate the absolute value when we did it. We didn't necessarily talk about what absolute value was at that point in time, but we talked about how to find it. So what my equations are going to look like today would be something like this. If I say, what is the absolute value of x that equals 8, what we're really asking ourselves is, what number or numbers can I plug in to x that make this equation work? What number can I take the absolute value of that would give us positive 8? 8, okay. Or -8, yeah. And in some cases, you could write your answer like this if it's the same number. Now, I will tell you this today. Most of the time, your answer won't be the same number. It won't be a +8 and a -8. It might be a +3 and a -5, okay? And I'll show you why here in just a second. But if it is the same number with a plus or minus sign on it, then you could write it either way, okay? 8, -8. But you got to have both answers. A lot of the problems that we do today will have 2 solutions to them. Not every single one, okay? But a lot of them will have 2 solutions. I would say the majority of them will have 2 solutions. Okay, so that one's a pretty basic one, right? Because we're trying to figure out what can I put into that absolute value that would make it equal 8. Then we're going to start getting a little bit more difficult as we go. The absolute value of 2x minus 5 equals 9. So here's the way we're going to think of this, right? If I had something inside the absolute value, okay, I would need this to be either a 9 or a -9 on the inside, right? Because if I take the absolute value of 9, I know it gets me 9. If I take the absolute value of -9, also gives me 9. But I need this expression, 2x minus 5, to equal those two values, okay? So what we're going to do here is we're going to write out two equations. We're going to say 2x minus 5 equals 9. And we're going to say 2x minus 5 equals -9. Because we know 9 and -9 are the two values that give me back to 9. So we got to figure out now what value of x would make that happen. And so then it's just solving two equations out, okay? And once we have the two equations set up, what we just can't forget to do is to set up the two equations, okay? Probably the most common mistake on absolute value is we forget that there's two answers involved. So we got to make sure we have both answers as we do it, okay? So now we're going to add 5. We're going to divide by 2. I get x equals 7. Okay, same thing over here. We're going to add 5. We're going to divide by 2. X equals 7. X equals -2. One thing that we've talked about, even since chapter 1, is whenever we have an equation, we can always check our answer, okay? And I highly encourage you to do that. Especially if you have any doubt, if this looks right or feels right, then I can always take these and plug it in. I know a lot of times we don't take the time to do that because it's like an extra step, but especially on a quiz or test, why wouldn't we do this is my question, right? I can take 7, 2 times 7 is 14, 14 minus 5 is 9, absolute value of 9 is 9, okay? You don't have to show any work or anything like that. You don't have to show me you checked it, but then I know that 7 works. Same thing with -2. 2 times -2 is -4. -4 minus 5 is -9. And when I take the absolute value of that -9, it gets me back to +9. Both answers work. Both of them are indeed solutions for that equation. Okay, this one very, very similar. When I get the equation written out here, we're going to write two separate equations. 3x plus 4 equals 8. 3x plus 4 equals -8. And then we're going to solve it, okay? Now, I gave you this one because we're not always going to get a nice whole number. It's very similar to the last one, but I get an answer of 4/3. Okay, and we've talked about this a little bit, but whenever we have an answer like this, I would much rather you leave it as a fraction because the decimal for 4/3 is 1.3 repeating. We don't want to round that number. We want our answer to be an exact value, and 4/3 would be the best way to write it. Okay. So whenever dealing with something like that, don't try to change it to a decimal. Don't try to divide 4 by 3. There's no need to do that. Just leave it as a fraction. Reduce it if you can reduce it. If it doesn't reduce, then just leave it as it is. Same thing on the second one. And then divide by 3. Okay, so this one ends up being a nice integer number. Okay, the other one is a fraction. And those would be our two. Still able to be checked, okay? And once again, okay, I'm not going to go through the check on every single one of these, but even 4/3, you might say, oh, that's going to be really hard to check. Not really, okay? You could even put it into your calculator. You could take 3 times 4/3, and what's going to happen then is those 3's are going to knock out. You could put it into the calculator, and then just add 4 to it, and you would get 8. And then the absolute value of 8 would be 8, and so it works, okay? So it doesn't take much to check it, even with fractions. You got your calculator that you can use, and that becomes a pretty good tool to help you to check as well. Okay, this one a little bit different. Usually when we see absolute value, we know immediately that I'm going to have to write out two equations, right? This one is different because what makes 0 different than any other number? There's no negative, right? 0 is just 0. There's no positive 0. There's no negative 0. Every other number that we can think of has a positive and a negative. 0 is the only one that doesn't, okay? So that's what makes 0 different. And so here, there's no need to do 2x minus 1 equals 0, 2x minus 1 equals negative 0, because that doesn't even make sense, right? There is no such thing as negative 0. 0 is like right in the middle of the number line. And so this is one of those few instances where I'm not going to get two solutions. I'm going to get one solution because 0 is the only thing I can set it equal to. And so we add 1, we divide by 2, and we get x equals half. And that's my only solution. Okay? So I told you at the beginning that majority of the time you will get two solutions. Here's one of the exceptions to the rule. Okay? If it's equal to 0, then we will not be able to do two equations. Up to this point has already had the absolute value by itself, right? Morning. If I didn't have anything inside the absolute value here, okay, I've got absolute value, and I'm taking this problem, what would I have to put into the absolute value symbol to make this equal negative 3? What happens if I take the absolute value of 3, let's say? What would I get? 3, right? What happens if I take the absolute value of negative 3? You also get 3, right? So what number could I put into this absolute value that will give me a negative? There would have to be a negative on the outside. That's true, okay? And since we don't, okay, is there any number that I could put into this absolute value that's going to make this equal a negative if there's no negative on the outside? No, okay? So here's the deal. Anytime I see an absolute value equal to a negative at any point in the problem, then immediately I can jump to no solution. Okay? And I tell you that because here's what a lot of people will do. They won't necessarily pay a whole lot of attention. They just get in the habit of solving, and they just want to set the two equations up and work them out. And so a lot of people will do 5x minus 2 equals negative 3, 5x minus 2 equals positive 3. It'll set the two equations up, and then they will solve them, right? And they'll get two solutions, and everything looks good. So that would be an example of why you would want to check. Because the two solutions that I would get here, if you did do two equations, aren't going to work, okay? Like, I'll show you one, for instance. If I plugged in 5x minus 2 equals negative 3, if I add 2, I get negative 1. If I divide by 5, I get negative 1/5. Okay. If I take this number and plug it in, 5 times negative 1/5 would be negative 1. Negative 1 minus 2, it is negative 3, but then I got to take the absolute value of it, and when I take the absolute value of negative 3, it gives me 3, okay? And so there is no number that's going to make this work. So this does not work out. And so that if you happen to miss it, that you didn't see it was negative over there at the very beginning, then that's when you would want to check it and say, oh, hey, wait a second, it doesn't work. Why doesn't it work? Well, it doesn't work because nothing will equal a negative. Okay? So no solution. And that would be the other example where you may not get two solutions. Kind of like it is here, right? I don't have anything on the outside of the absolute value equal to some number. And so that's the way we want to get our equation set up as, if it's not already there. And so every one that we've done, absolute value of 2x plus 1 in absolute value, plus 6 now is on the outside of the absolute value, equals 4. Okay, whenever we see a problem like this, our goal is to get the absolute value all by itself, okay? I want the absolute value on a side all by itself. This one doesn't. So we got to get the absolute value by itself first. We got to move everything to the other side. So what do you think we would do? Subtract 6. So that gives us the absolute value of 2x plus 1 equals negative 2. What do we notice? Yeah, it wasn't like this at the beginning, but now I see absolute value equal to a negative. Okay, so even as we start to solve these problems out, what I'm going to have to pay attention to is if at any point in time the absolute value is equal to a negative, there is no number that's going to make this happen, guys. Okay, there's no number that's going to make this work. And so I could immediately stop right here and say no solution. So you almost have to kind of keep your mind in yourself for that. Like, okay, do I have absolute value equal to a negative? If not, I can keep solving. But if I do, I'm going to just stop right there and say this is not going to work. Okay, unless you have something else on the outside of the absolute value you still got to get rid of. Okay. This one is kind of a doozy. It's got a lot of stuff going on in it that typically get missed. Okay. The first thing that gets missed here, immediately people see an absolute value in the problem, they see a negative 6 over here, and a lot of people will think, oh, this is a no solution, okay? Might be, okay? But can we determine that right now? No, because we still got some things over here that we have to get rid of. The absolute value has to be by itself equal to a negative. I can't just look over here and say, oh, I got a negative 6 over there, so this has got to be a no solution. And I mean, it might be, but we can't just jump to that conclusion unless this stuff wasn't here, okay? And then we could do that. So what we got to do now is we got to get rid of this stuff here and then see what we got. Okay. Where do you think we would do next? Any ideas?
Take the absolute value of 2 minus 3. Is that 12 or is it?
Oh, sorry, that's a 12. Yeah. I think my one kind of made that look like it, didn't it? Yeah, this should be a 12 right here. Sorry about that. It did look like absolute value. 12 minus 3 times the absolute value of 3x minus 6 equals negative 6. Okay? That's a great question because it didn't look very good. I didn't do a good job of writing that up there. I tried to make my absolute value sense a little bit bigger, but it probably was a little confusing. Okay, so now that we know that's a 12, any thoughts on what we could do? You'd have to subtract 12, okay? And here's the two mistakes that will typically get made here, okay? First of all, you cannot combine these together. This 3 is connected to the absolute value, and I cannot combine these two, okay? I also cannot distribute throughout the absolute value. Absolute value is different than parentheses. If it was parentheses, I could distribute the negative 3. I can't distribute when I have absolute value. Okay? It's more of an operation than it is a grouping symbol. Even though it's still considered to be a grouping symbol, that's why we can't distribute through it, because we're performing an operation. We're taking the absolute value of something. So I'm going to get rid of the 12 first. Okay? And the way that I would think about this, and where we've probably seen it more. Good morning. If I just wrote something like this up here, without the absolute value and all that, I think we could probably solve something like that a little bit easier, right? That looks a little bit more familiar to us. And it would have the same steps, essentially. So the first thing we're going to do here is we're going to subtract 12. And we get negative 18. Okay, now what? Divide by negative 3. Good. Okay, a couple things we're going to notice here. Originally, I had a negative up here, and we said, oh, it could be a no solution, right? But now as I look at the number I have down here, the absolute value is by itself, and we're equal to a positive number. So is this going to be a no solution? Nope, we're going to have a solution here, right? Because it's equal to a positive. And so here is where we can do like we've done on the others, bless you. I can set 3x minus 6 equal to 6, and 3x minus 6 equal negative 6. And those are our two equations. And now we can solve. We get x equals 4. Here, if I add 6, I get 0. Don't freak out on 0. 0 is a number, just like any other number. I can have an answer of 0. 0 is okay. 0 doesn't mean no solution. Those are two different things. So those are my two answers. X equals 0 and x equals 4. So once again, I get two solutions. Okay, the last couple I'm going to put up here. These are going to be a little bit different. I don't know if you've ever seen ones like this before. I think you've seen some of the absolute value equations before. But these last couple, I'm not sure you've ever seen. You still have absolute value. But we have absolute value on both sides. Hey, so when we solve this one, we're going to basically do it the same way that we've done the others. Three x plus 5, whatever's inside that absolute value, is going to equal x minus 9. That one's pretty straightforward. So you're going to rewrite it without the absolute value symbols in it. That's going to be one of my equations. Okay, the other equation, this is the part that's a little bit different. Okay, what we've been doing all day long today is we set it equal to the number and we set it equal to its opposite. So like 8 and negative 8, right? Well, here, we're going to do the opposite of x minus 9. And I want to put that x minus 9 in parentheses because what I'm going to have to do is distribute this negative throughout. Because it's not just a number, it's an expression. And so I got to change the sign on everything within that expression. So we're still doing the opposite of this, but we got to do the opposite of the whole thing. Okay? If you really wanted to, you could just go negative x plus 9 and just go ahead and change them right as you write it out. And that would be okay too. So now we're going to solve these two. We're going to subtract x. So if I move my x's to the left, I'm going to move my numbers to the right. And we're going to divide by 2. Okay, over here, like we said, we're going to distribute that negative. Okay, both of these should work. And so let's check it here. Let's try 1, because 1 will be easier to check. 3 times 1 is 3. 3 plus 5 is 8. Absolute value of 8, still 8. Pretty straightforward. 1 minus 9 is negative 8, but when I take the absolute value of negative 8, it gives me 8. So I end up with 8 on both sides. Negative 7, 3 times negative 7 is negative 21. Negative 21 plus 5 is negative 16. But when I take the absolute value of negative 16, it will give me 16. And when I take negative 7 and plug it in here, negative 7 minus 9 is negative 16. Absolute value of negative 16 is positive 16. And both sides equal 16. So when I plug both of these numbers in, both sides are equal to each other, which tells me we've done something good. Okay? And so here's another one that I would highly recommend checking, okay, because it's different. And you got to plug it into both, take the absolute value of both, and just verify that they both work, okay? So especially like on the test next week, when you take and do these absolute value problems, I can't stress enough that why not check it, right? There should be no doubt in your mind, like when I hand my test in, I've got that problem right, because I checked it and I got it right. You shouldn't have to wait for me to grade it, right? Because you already know you got it right. Can't say that about every single problem. It'd be nice if you could check every single problem. But on the ones that you can check, take advantage of it and know you got it right. Okay, that's all we got. Okay, we got some time here to work. We need to start taking advantage of the time we have. Let's see what we got about. Got about 10 minutes or 15 minutes or so that you can work. Work on yesterday's, you can work on today's.
Is there a video of Google Classroom for yesterday?
Do what?
Is there a video of Google Classroom for yesterday?
Let me make sure I posted it. Yeah, there is, Jacob.